Okay, number 4 is parallel, but why? What was the question it was answering? Yeah, slopes are the same, right? Slopes are equal, slopes are the same. Good. Okay, number 10 is a matching thing. Did A go with L2, B go with L1, C go with L3? Does that all make sense?
Yes.
Oh, okay. I said no. I didn't think that was a typo, but it might have been. Pre-cal was all talking right around here, but I don't know why. So I just shushed them and we moved on. 56. Did it matter what point went into point slope form? Ooh, we did not have a confident answer on that. Did it matter which point they put into point slope form?
No.
I don't know.
Because it would have been y plus 4 and x plus 4. It looks so different, but what did you still have to do?
The rest of the work.
Yeah, guess what happens? Whoever you plug in, as long as it's a point on the line, it'll look different here, but what will, as long as you do it correctly, what will always happen?
You get the same.
Yeah, you'll get the same answer. So some of you might look at this and be like, oh, I did it wrong. No, you didn't. If you plugged in -4 correctly and simplified correctly, you should have gotten the exact same answer. Slope you would have had to find with the slope formula, 7/8. But either way, whatever points you plugged in, as long as they're on the line, that's your final. What form is this again?
Point slope.
Because?
There's a point here.
Pause. That's not point slope. That's point slope.
Oh.
Because there's a point and there's a slope. Who's this?
Oh, slope intercept.
Slope intercept form. Because you have a slope and a y-intercept. Standard form, what does he look like? Because we're getting them all confused.
AX
plus BY is C. Find me a problem in homework that started off with a standard form equation. Find me a problem in homework that started off with a standard form equation.
73.
Let's go to 73, just because I recognize that from this morning. But yeah, there might have been some other ones too. What's going on in number 73? People this morning didn't like it. Or last. Sorry, things got updated. It's not working the same. Don't die. 73 was a honking problem. Does anybody have any questions on 73? No, because you're honors. Ooh, Alec, what's your question on 73?
I didn't know what to do.
Good, thank you. That's exactly what I was looking for. What were you given in number 73? A standard form of a line and a point. Now, if you plugged this point into that line, is it a, well, you guys can do mental math here in honors. Plug it in right now in your head. Does it work or no?
No.
So who is that guy? 8 minus 2 is not 3, it's 6. Who is this guy? He's not a solution. He's not a point on that line. What is this supposed to be a point on?
Oh, you have to.
Other line. So we're trying to make another line that has this point. So this point is for these guys. So you have this other line, and then a point that's supposed to be on a line that's parallel to the given line, and then another line that's perpendicular to the given line. So could you have graphed this line? Sure. And drawn that point? Sure. And it wouldn't have been on there. Then you would have tried to figure out what's the line that goes through that would be parallel or perpendicular. But to answer this, or to answer that, or even just to graph that, do we like standard form? No. So what, hopefully, did you do in homework if you knew how to start?
Get y by itself.
Get y by itself. When you got y by itself, did you guys end up with 2x minus 3/2?
Yes.
Yeah.
Nice. Is that the answer to either A or B?
No.
No, he's the other line we're looking at. But could you have, if you wanted to, graphed the y-intercept at -1.5, and then gone the rise over the run of up 2 whole units, which will get you to +1/2, and then over 2. Wait, up? No, it's not up and over. What am I talking about? What's our slope, guys? over run.
It's because the red marker's on.
I know, but see how it's like hidden there and I can't get to it? Oh, you just do it enough and it goes away. So my rise should be up 2 over just 1, right?
Yep.
There we go. And where's the 0.21? So if I told you to draw a parallel line, could most of you do a pretty good job drawing a parallel line? Probably. If I told you to draw a perpendicular line, how would you guys do that?
Cross it.
Really? You
Just
like,
tilt it to the side.
Yep, just-
Straight
just-
to the side.
does anybody have a way to do it pretty precisely?
You do the reciprocal slope.
Okay, that's the way to do it algebraically. How about just like a drawing without using any math, any equations? Alpha.
Draw a square.
Yeah, but that's assuming we can all draw perfect squares.
I can't.
What do all of you have on every corner of every piece of predetermined paper that you have?
A straight line.
2 straight lines coming together at n. Every edge of every corner of your paper is a right angle. Couldn't you take your really cool right angle paper and couldn't you line it up to one edge of the paper is here and then you just move it until, oh hey, there we go. Okay, so you could do it pretty precisely, just not with the whole eyeballing thing. But yes, I'm going to eyeball because I don't want to get a piece of paper and trace it. Oh, well that didn't work anyway. So how do I find that? And how do I find that with math? Why am I doing this and not any other form? Besides the fact that I have an agenda that I have not made hidden in any way, shape, or form about how this is important for calculus. Why else would I use this form? But why not slope-intercept? Why not standard? That's not an intercept. I can't plug straight in anywhere except for here, right? As far as like a proper place of the normal plugging in. What else do I need to put? Parallel. I keep the slope the same as what? This one, same point. I have my 2. I have my 1. Pretend that's it. Who's my slope going to be? And Alec, all you gotta do is distribute and get y by itself. And then distribute and get y by itself.
Wait, what form did you?
Point slope.
Okay.
Now, could you use slope intercept form? My people that are diehards and really like that one. But how? For parallel, you would have done 2x, right? For perpendicular, you would have done negative 1/2 x. But who don't you have that you wish you did? But you do have the 0.21. So even though it's not like the proper plugging in, you technically can still put it where? You can plug in the y coordinate with the x coordinate and say, who was b? And b is equal to -3. And you're like, oh. Which is the exact same thing. This one doesn't get you to the form. By plugging in the point, it doesn't get you to the form of the line, the linear equation, but it does get you the pieces to get there. This one would get you straight there, because it'd be 2x minus 4 plus, just kidding, 2x minus 2. Did I plug him in wrong? I did. Are you guys going to stop me, or are you just going to like chuckle to yourselves off to the side?
Why did it do that?
Because I'm in like this weird screenshotty thing. What was supposed to go there?
1.
Because it's that y value. What's supposed to go there?
Struggle.
Now we have 2x minus 4 plus 1, which is 2x minus 3. And over here we have negative 1/2 x plus 1 would be, I believe, did you guys get negative 1/2 x plus 2? As your perpendicular? And y equals 2x minus 3 as your parallel? So you could have done, I'm not going to do this one, but you could have done slope intercept form if you really wanted to. You just didn't have to. And I'm, once again, having a huge agenda for you guys getting used to point slope form anyway, so I'm using it as much as is possible. And in this one, he was not an intercept, so I said, forget it, let's use point slope form. Okay, my mouse. Who sees my mouse? There it is. Okay, anything else from homework that you guys want to see? Or is there anything from homework? Yeah.
Number 51.
51? 51, you're supposed to find an equation of a line given funny clues. And the funny clues that you guys have involve a point, and an undefined slope. What did we talk about yesterday with undefined slope? When would you be undefined? What kind of slope would you be skiing?
Cross country.
Dead.
Nope, that one's boring. When would you be undefined?
Dead.
That one. So, what do death slopes look like? Well, it's yellow now. What do death slopes look like?
X equals Y.
X equals a constant. And it has to go through this point. Well, if x has to equal a number, it has to go through that point. What's the x of the point? So guess what? Would the line x equals 6 go through the point 6, -1, and have an undefined slope? Yes. Tricky. Tricky, tricky. Anything else from homework that you guys need to see? Evens or odds? Going once. Going twice.
I forgot to take a picture of the homework last night.
Oh, you didn't submit Google Classroom?
No.
What do you guys think? Still early enough in the year we should give grace?
Yeah.
Just a little bit?
Alex.
Do we believe Alec?
No.
Look at his face. Jaden says no.
No.
But he's smiling. I don't know if I trust Jaden smiling. All right, go ahead and Alec post it tonight and then write me a comment telling me exactly what you just said.
Oh, yes.
I forgot and my class had grace. Sound good? Well, Jesus loves you no matter what, even when you make mistakes. But it doesn't mean you can always escape consequences. But this time, okay. We'll excuse it. Here we go, section 1.4. You guys were even good on number 109? You aced it?
109.
Okay. I mean, that one wasn't too bad as long as you knew what you
Oh,
were
that
doing.
one was good. That one was good.
How about number 91? You rocked that one too?
No, that one was weird.
Was Cowshot right or wrong on number 91?
It was wrong.
Oh, that's what I wanted to hear. Okay, sometimes your question might not be on the question itself. Maybe it's like, did you know the Cowshot was wrong on number 91? Now, I kind of wish you guys were before my regular pre-calc class. Because then you could help me out with the problems of the day. But that's all right. We figured it out eventually in pre-calc. Walk me through real fast. Who wrote this entire paragraph down? You didn't need to. Who summarized it? Okay, to what? Kathy, what did you write for the summary?
You're given the dollar value of the 2013 product. The rate at which the value of the product changes in the next 5 years is $125 increase per year. Write a linear equation that gives the dollar value of the product in terms of the year t equals 13.
So you kind of got this up into there, huh?
And
Sounded
the
like
value of the product is $25,040.
Okay. Did anybody summarize it even shorter? So she kind of got some of the information up in there. Who summarized it even shorter? Sophia.
I just put 2013 to 540 and rate 125.
Good, except I'm not sure in a week you'll have any clue what that means. So careful. Oh, did you write something up here? Did you write anything up here? Okay, so you knew you were supposed to make an equation. I would have probably done something about you're dealing with the value of a product. I would have probably done something like that. Because then we could be like, oh yeah, there was this product and we were dealing with him and trying to make an equation given this information. The next 5 years, did you actually have to use that at all? No, but would it be a good model? The equation that you make is called a model, a math model. Would it be a good model to use in like the next 10 years? What's going to happen? Once you get the equation from this information, would it be a good model to use in 10 years to be like, oh, what's going to happen in 10 years? We'll get back to that question. Let's make the model first. So, what did this guy end up becoming?
Negative
Oh, wait, no,
125.
Negative 125 was what variable, though? If we're making a line, we're thinking y minus y1. Why is it slope? How'd you know?
It's the rate.
It's the rate of change. Rate is slope. And if you think, what would put together the y, the money, and the x, the years? And actually, it's not even a y. Isn't this really a v for value, and isn't this a t for time?
Yeah.
What kind of value takes changes in money over changes in time? Rise over run, slope. Okay, so this ends up being slope. Who's that guy? Initial, or a point, or a value that we can use. So what did you guys make your x and make your y, even though it's a t and a v, but who was your x, who was your y from this clue?
13 was our
13, because we're not using 2013, we're using how many years from 2000? And, oh, just the money, right? The value. We have a point, we have a slope, and what do we do with point slope? Plug it in. But wasn't your equation actually supposed to look like this? With v's and t's instead of x's and y's? Did you guys get that? But what was the mistake that CalcChat made? You put in a 10. And 10 makes no sense, because that'd be the year 2010. So CalcChat failed. I think the back of the book was right. Back of the book was right, CalcChat was wrong. You would have wanted to get v by itself, and technically, if you remember function notation, v of t looks a lot nicer than just v by itself. And then you can end up getting your negative 125t plus something with a 4. What did you guys get?
4165.
4165. And is it positive or is it negative? Oh no, it's a positive and a positive. Yeah. There we go. So CalcChat was wrong. So if some of you guys right now are looking at a CalcChat answer that wasn't right and didn't make sense in context of the problem, you should be thinking, maybe that's not a good way to do homework.
Wait, so
That would have just been regular pre-cal, right? Honors would just steal from CalcChat. Jane, go ahead.
do you distribute the 125?
Yeah.
Okay.
You have to distribute first and then add and then combine 13 times 125 plus 25.
Okay.
How I would have summarized it would have probably been something like dealing with the value of a product, given its 2013 value 2540 and its approximate rate over the next 5 years of negative $125 per year. Find a linear equation. That probably would have been my summary of like the whole shit. But alright, cool kids. You can probably see why pre-cal struggled with it. Most of you said you didn't, although it was tricky. And we got a warning that CalcChat, well, just stealing from CalcChat is never a way to do homework, especially when they're wrong. But back to the whole never the way to do homework. Are we tracking? Do it yourself. Okay. And then come with questions, because as you can tell, I give grace to questions when you come with them, as long as you've attempted them. No, I don't want to save the changes to my PDF or to that. Section 1.4, let's go, guys. Let me block whoever's popping up. Okay, any quick questions on logistics as far as how we're doing in Google Classroom? All the forms should be turned in at this point. I have a few that are trickling in. People are getting in Google Classroom late. They realize their parents didn't actually turn in the forms. Just write me comments if there are excuses, etc., that you think I should pay attention to. You guys are great on expo markers and textbooks. We'll finish up tomorrow. Okay, anything else we need to talk about? Let's go. Functions. Okay, functions. There's a lot to do with functions. I don't think we're covering all of it in section 1.4, but we're getting it started. Since you're an itty-bitty kid in like Algebra 1, which wasn't that long ago. Hopefully you've been talking about relations versus functions. Relations, any set of ordered pairs, any collection of data that's somehow relating two different quantities. In homework, we had something weird like value and time, dollars and years. But sometimes you have a really boring equation that just has y's and x's, and you're like, I have no idea what this represents, but okay. But sometimes you have actual representations of actual data. Your variables could change, just a quick heads up. But what makes a function? It's a special relation where what? Each x paired with one and only one y, but didn't we just say we don't just have x's and y's anymore? So maybe we should call x by his real name, independent variable, which is usually an x, but not always. Y, let's call him by his real name, a dependent variable, usually a y, but not always. But did you guys already fill in the blank? What's the test that we can use on a graph to see whether or not what is shown is a function? Yeah.
The vertical line test.
Yeah. The vertical line test. Because if vertical lines, quick reminder, need it in homework, if vertical lines are x equal constants, each x can only hit one line. If it hits more than one line, by definition it can't be a function, because each x would not be paired with one and only one y. So then you guys got to the examples on this next page. And if you're a mathy person, you probably didn't mind any of them except for letter A. Because the other ones are pretty straightforward. Let's check out that table and let's check out that graph and make it a little bit bigger if I can. There we go. Let's forget A for a second. He's kind of annoying. How about letter B? Function or not function? Or I should say function or relation. Letter B, function or relation?
Function.
Relation.
Why can I only say he's a relation and not a function?
Oh, because we're multiple.
If I was to graph these, wouldn't I have at x equals 2? Wouldn't it hit at both 10 and 11? One input putting out two outputs, so that's not good. Not for a function. He's only a relation, not a function. Each x, if x is 2, can only go with one y. I could have more than one piece of data going to 11. I could have this 2 going to 11 and that 2 going to 11. I just can't have a repeated x go to a different y. I could get into more depth as to like you guys feeling this. Like if you ever have had a teacher that's inconsistent, where like you turned in work and you got one grade and someone else turned in the exact same work and got a different grade, you're like, that's not fair. One input. Oh, well, you both turned getting different results. Your graphing calculator. Let's forget about the graph. Let's just talk about the home screen. Don't you expect the graphing calculator, you to give it something and it to give you one answer and one answer only? And what if you kept on putting in that same thing over and over and over and over again? What would you expect the calculator to keep doing?
Same thing.
The same output. Why? Because the calculator is built on, in a sense, hey, can you guys in your calculators open them up and hit the mode button? The mode button? Does your calculator operate in function mode? What do you see? There's a lot of different things there, but what do you see? Is there an F-U-N-C? Function mode. Now there's other stuff. There's a PAR and a POL and a SEQ, and by the end of the year you'll know all of them, at least kind of.
Parametric.
Parametric. Close. Polar and sequential or sequence. But your calculator operates in function mode. So when you go to your y equals, any equation you put in can only have x's. You can't have any other y's, and you can't square the y. All because it operates in function mode. So sometimes in life it's very practical where you want an input to only have one output, and if it has more than one output, well, we have some issues. How about this graph when we're looking at it?
It is a function.
Why?
Because it
It's the
passes the
same.
multiple test.
You can put it that way. It passes the vertical line test, or you can actually start getting particular that each x has only one y. They don't have any overlap, right? Now the y's, there are some y's with more than one x's, but we don't care about that. At least not yet. Not until we learn about a horizontal line test with something called inverses of functions. But that's later. Okay, let's get back to that letter A. Some of you were like, ooh. Some of you were like, that's awful. Can we make a table? I'm a mathy person. I like to see numbers. X's are supposed to represent, oh, hey, representatives from states. How many representatives? Y's are supposed to be for senators. Do you guys know which one stays the same always, 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 regardless of whatever state you're talking about?
Senators.
Good. How many senators does every state have?
2.
So regardless of how many representatives, you're going to have 2 senators, right? Why do the number of representatives change?
Because some states are bigger than others.
Population. Good. Okay. Are there some states that might have similar enough populations that they have the exact same number of representatives?
Yes.
Yeah, it's possible. Now, I don't have all the states and all the representatives memorized. If you do, props. We're not taking time for it, though. We could go ahead and start writing down, oh, this state has this many representatives, this state has this many, this state has this many. And you might have some states with repeated, or I should say, with repeated numbers of representatives. Like you might have, what would be 2 states that would have similar populations? North and South Dakota? I'm just somewhat kidding and somewhat not. You could have 2 states with similar enough populations that the representatives are the same. But even if an X is repeated, what's not going to be a problem? Look, a repeated X, different Y's. No. But in this case, if an X is repeated, it doesn't matter because why? The Y doesn't change. Now the Y doesn't change for anyone, which makes it extra safe, but the Y wouldn't be different for repeats of the same number of representatives. So even if there were repeats, which there probably are, it's not a problem because it's not to different outputs. It's still going to 2 senators. So therefore, this would be a function. Repeats in the X's are possible, but I should say function singular. Repeats in the X's are possible, but it will not pose a problem because it's not possible in this example to have it go to different Y's. That'd be fun. How was the data given to you in letter A that you were supposed to analyze?
Words.
Words. What's a snazzy way of saying words? Huh? Okay, word problem, maybe. Let's go to this one. We'll work back to that one. How was the data given here?
A graph.
In a table. And wasn't there a vocab term, not today's homework that was due, but yesterday's? Anything given to you in tables, it's called what kind of data? Numerical. Or it could be given to you numerically. What's this guy? So how was the information given to you? Graphically. So this one numerically, that one graphically. Okay, how can we put words? Wordly? No. How could you put that? Verbally. Yeah. So the 4 different ways of presenting math. Verbally, numerically, graphically. Wait, so what's algebraically?
In a function.
Yeah, in like an actual equation. Now, I know you were saying function because you're used to all equations being functions, but are all equations functions? No. What was the graph that we saw the other day that exhibited x-axis symmetry? And so by definition was not a function? Do you guys remember the equation for it? The graph looked like this.
Parabola.
It was a parabola, but it's sideways. What did it look like? Not y equals x squared, but
Equals y squared.
x equals y squared. Now, could you put x equals y squared into your graphing calculator underneath the y equals menu? No, because your calculator is built on function. But is it still an equation that still has a graph? It would just be called a relation instead. And don't worry, there actually are, well, maybe you should worry. There are ways to graph non-functions in your calculator. We just have to be very creative because it was built upon just dealing with functions for the very purpose that we stated. One input, one output. That's how computers work. Mostly. So you guys could probably just go ahead and fill in what's missing. Verbally, how's the data given to you, or how's the information given to you?
Words.
Words. Numerically. Yeah, some sort of numbers, some sort of numeric data. You could also say usually, I'll put numbers, but usually in tables, that's how it's organized. But if you ever open like a statistics book, you might just see a list of numbers and you're like, oh. It would still be a table, but it could be given to you different ways. if you were to go out in the street and do polls of people, you could just have like little slashes keeping track of who answered certain questions certain ways. That would be an example of numeric data, even though you don't necessarily have a table yet. Graphically, that's easy. Yep, somehow it's in a graph. And then algebraically, don't say functions, because remember, there's just say equations. Somehow it's given to you in equations. And so example number 2 says, let's go back and talk about the example we just did, but we just did that, so the one way that we didn't talk about, is it a function or is it not, is algebraically, but I just gave you an example. So let's do an example for algebraically. Let's write it down in our notes really quickly. What would be a relation, not a function? Relation's the best way to characterize it, versus a function. What's an example of a relation for an algebraic equation that I just gave you?
X equals Y squared.
X equals y squared. He fails the vertical line test. He has x-axis symmetry. He's a relation, not a function. So then what would be an example of a function?
Y equals X
Sure, we
squared.
can do that one. Or there's, like an infinite number of other possibilities. But I think that's where my brain is going to. So that might beg the question, the graph, I can think vertical line test. Numerically, I can look for repeated x's and see if they go to different y's. Verbally, I want to make it look like a table or a graph. So how could we algebraically see if it's a function? Maybe just get really good at knowing what all equations look like.
Yes.
Probably trying to somehow visualize a graph or somehow look at a table. Which isn't an easy answer because depending on the function, that could be very messy. But to be honest, that's probably the best way. There's not like a nice x-axis, y-axis, origin, symmetry test for functions because equations can look so differently. So different. I can dual page just in case some of you guys got left behind. But we're moving on to translating. Even though verbally, numerically, graphically, it's great, it's good, to be honest, what most of you are more comfortable with would be algebraically when given data. And to be honest, what's more practical, more useful, more helpful in most circumstances for our purposes in pre-calculus is algebraically. So what if they give us words? How could we put it into math? Well, here's some important things to remember. And I think most of you should be done with the page before, so can I even give you a purpose as to why? Because some of you are like, I don't know. What if you had this huge paragraph, like the example on the next page? You guys are writing down clues. Let me just read the example problem. You work in a marketing department of a soft drink company and are experimenting with a new can for iced tea that is slightly narrower and taller than a standard can. Arizona iced tea. For your experimental can, the ratio of the height to the radius is 4. Letter A says, write the volume of the can as a function of the radius of R. Basically, A says, cool, give me a volume formula. A volume equation using all the information from above. Which some of you are like, okay, let's go. Some of you are like, there were way too many words.
I agree.
So here is the first line of defense, or here is the first thing that you should tackle. You should see, is there wording of, is a function of? Is there wording of, depends on? Or is there a meaning of, depends on, even if it's not explicitly stated? Because if you can find in any of the information that wording, you can already figure out who is your dependent variable versus who is your independent variable, which might be an x, might be a y, might be a v or a t or an r or an h. Could be different variables. But still the meaning is the same, to where the first one that comes in that phrase is the dependent one, the second one is the independent one. Which kind of makes sense in depends on, because well, if something depends on, it's dependent. If it's depending on, well, this guy is independent of him, at least in some regards, mathematically speaking. But if you see something like is a function of, or is a function in terms of, you can make that same deduction of the dependent comes first, the independent comes second in the wording. And remember, we also talked about how independent is like the input, if that helps sometimes. The dependent is like the output. Sometimes you can kind of get that feeling from a problem depending on your variables. Now looking over here, I think the highlighting is a little bit too dark. It's kind of hard to see all the words. It's light on my screen, but dark when it gets projected. Can I steal them? There we go. Do you guys see that wording anywhere over there? Any hints, any clues? How would you summarize? Marketing. Designing a new iced tea can. Where ratio of the height to the radius is 4. Oh, those are words. Guys, can we translate words into expressions if possible? How can we translate the ratio of the height to the radius is 4 into a mathematical expression? H to R?
H to R is 4.
Yeah, I like it. H to R is 4. But what's the best way of expressing H to R is 4? Because there's 3 different ways to show a proportion. You guys remember this? There's the word to, there's a colon, or there's a fraction bar? Yes. Be confident. You're okay. If you're wrong, I won't humiliate you. I'll just point you in the right direction. The ratio of H to R is 4. Your marketing, trying to design a new iced tea can where H over R is 4. You could put the extra information, but I think based on what I read down below, it's actually not important. Now letter A says, right, the volume of the can. Okay, well that's V, right? As a function of the radius R. Oh, stink. I think they're expecting me to remember some math from my prior knowledge. Well, what does an iced tea can look like? What shape? What's the volume formula of a cylinder? Did you guys know that the front of your book is really cool? Because if you open the front cover, there are all kinds of old formulas. Some of you just covered up all those old formulas. There's also a thing called an iPhone, and Siri knows math. What's the volume formula of a cylinder? She'll let you know. I'll let you know right now because I'm nice. Area of the base, which is circle. What's the area of a circle?
Pi r squared.
You know that one? And then just translate it, extend it through the height. Boop, boop. There you go. So, if that's the volume formula of a cylinder, how am I supposed to write the volume as a function of R and R alone? No, H is allowed. Substitution. Plug it in, plug it in. We need another day. You already knew that. Homework is due on Friday. So your homework tonight is? Start. There's very rarely a night where there's no homework. The homework tonight is start, section 1.4. Bye guys. Thanks for waiting. I'll see you later.